Imagine opening your favorite AI chatbot and getting an answer almost instantly. No long wait, no loading, just fast, natural conversations. Now imagine every AI assistant becoming dramatically faster while companies spend less money on expensive GPUs. You'd probably assume someone built a revolutionary new AI model, but that's not what happened. Instead, DeepSeek has unveiled something called DSpark. It's an engineering breakthrough that can increase AI inference speeds by up to 80% without changing the intelligence of the model itself. This isn't about making AI smarter. It's about making today's AI dramatically faster. And if this technology spreads across the industry, it could change the future of every AI chatbot we use. Welcome back to the AI news. So let's dive in the story. So what is DSpark? Whenever a new AI company announces something, it's usually one of three things: a bigger model, a smarter model, or a model that beats everyone else in benchmarks. But DeepSeek decided to focus on something completely different. Instead of asking, how do we build a smarter AI? They asked, how do we make today's AI much faster? That may not sound as exciting at first, but once you understand how AI actually works behind the scenes, you'll realize this could be just as important as releasing a new model. Because even the smartest AI in the world has one major weakness: it's slow. Most people think AI responds instantly. You type a question, a few seconds later, the answer appears. Simple enough. But behind the scenes, something very different is happening. Large language models generate text one token at a time. A token is actually a part of a word or sometimes an entire word. So the model predicts one token, then it predicts the next, and then next. So like one by one, it keeps predicting, which is slower. So every prediction depends on the previous one. Imagine trying to write an entire book, but you're only allowed to write one word before stopping to think again. That's essentially how modern AI works. Even though companies use thousands of powerful GPUs, much of that hardware spends time waiting between predictions. Now, those tiny pauses might seem insignificant, but across billions of AI requests every day, they become so expensive. The larger the model, the bigger the delay, and the more money companies spend just waiting. So researchers have been trying to solve this problem for years. One of the most promising solutions is something called speculative decoding. Now, the name might sound technical, and you might seem that it's just a technical and fancy word. It might seem hard, but it's actually really simple. Imagine you're trying to message on your phone, and before you finish your sentence on the phone actually predicts the next word. And sometimes it's correct, and sometimes it isn't. Speculative decoding works in a similar way. Instead of making the giant AI model generate every single token by itself, so a much smaller and faster AI model predicts several future tokens ahead of time. Now, these predictions are called draft tokens. Then, the large language model checks them all together. If they're correct, it accepts them instantly. But if they're wrong, it simply replaces them with the correct ones. Now, the important is that the final answer doesn't change. The AI remains just as accurate, but it simply gets there much faster. It's like having a junior assistant prepare a draft before a senior expert reviews it. If most of the draft is already correct, the expert finishes the work much faster. Now, that's the basic idea behind speculative decoding, and researchers have been improving this technique for several years. Now, speculative decoding, it was not invented by DeepSeek. Systems like Eagle 3 and DFlash were already using these similar ideas, but they all suffered from the same limitation. Farther ahead, the smaller AI tried to predict, the more mistakes it made. And at first, predictions were very accurate, but later, predictions became increasingly unreliable. Eventually, the larger model rejected many of them. That created a lot of wasted competition. Imagine asking someone to write 10 pages of a report, only to throw away half of it because it wasn't accurate. Now, the work was done, but much of it was wasted a lot. So, DeepSeek believed they could fix this problem. And that's exactly what DSpark was designed to do. Now, the first major innovation is something called Semi-Autoregressive Generation. Now, just don't let that complicated name scare you. Here's what it actually means. So, the traditional speculative decoding, it actually predicts multiple future tokens independently. But language doesn't really work that way. Every word depends on the word before it. So DeepSeek realized that even while predicting multiple tokens in parallel, those predictions would still be able to communicate with one another. Think about a group project. If everyone works completely independently, mistakes happen. But if teamworks quickly share information while working, the final result becomes much better. That's exactly what DSpark allows. Now, its predicted tokens can partially depend on one another before they're verified. So the result is significantly higher accuracy, more predictions survive, few are rejected, less competition is wasted, and hence the AI becomes much faster. And the second innovation might actually be more smarter because normally speculative decoding sends every predicted token to the main AI model for verification, but DeepSeek asked one important question: why waste time checking predictions that are probably wrong? So they built something called confidence scheduled verification. Now, every predicted token receives a confidence score. Now, if confidence is high, system verifies it. But if the confidence is low, it skips it before wasting GPU resources. Now, resources are focused where they matter most. So DSpark applies a similar principle to AI inference. Now, it constantly decides which predictions deserve attention, and because the system adapts in real time depending on server workload, GPUs stay busy instead of sitting idle. So this dramatically improves efficiency. And now, DeepSeek also solved another hidden problem called GPU stalls. Now imagine an office worker who is not doing his task, like he's waiting for the task to be given by his manager or by the higher people, and he's sitting idly, like he's not doing any task. So what happens is that the office becomes much more inefficient. So GPUs face a similar issue. So if scheduling isn't handled properly, expensive hardware spends time waiting instead of computing. Instead of working, they are spending time in waiting. So DSpark introduces asynchronous scheduling and something called zero overhead scheduling. Now, without getting too technical, it means that it keeps GPUs continuously working, less waiting, more computing, and high efficiency. So it's another reason why DeepSeek can claim such dramatic speed improvements. Now, the result is that did it actually work? According to DeepSeek, yes. The company reports user generation speed improvements ranging from approximately 60% to 85%, depending on the model, across mathematical reasoning, programming, journal conversations, and coding benchmarks. Now DSpark consistently outperformed previous speculative decoding systems like Eagle 3 and DSFlash, as you can see here in the test. You can see here in the image, it has beaten Eagle and DSFlash. And even more importantly, this isn't just a research paper. DSpark has already been deployed in production for DeepSeek Flash and DeepSeek Pro, so real users are already experiencing these improvements. And one more thing, DeepSeek didn't just stop there. They, alongside DSpark, the company also open sourced an entirely new framework called DeepSpec. Now, instead of simply publishing a research paper, they released the complete infrastructure needed to train and evaluate speculative decoding systems. Now, developers can prepare data sets, train draft models, evaluate performance, and even experiment with different algorithms. Now, for AI researchers, this is a huge advantage. Instead of rebuilding everything from scratch, they now have a complete toolkit to use. Now, this could accelerate future research across the entire AI community. So, what do you think? Could engineering breakthrough like DSpark become just as important as launching brand new AI models? Or do you think companies will continue focusing on making AI bigger and smarter? Let me know your thoughts in the comments below. I love to hear what you think. So if you enjoyed this video and want to stay up to date with the latest AI breakthroughs, model launches, and industry news, don't forget to like the video, subscribe to the AI news, and turn on notifications so you never miss an update. Thanks for watching, and I'll see you in the next one.